Dear student, today we are going to start a new topic, that is mixture. What is mixture? Once upon a time, what happened, I was wondering to know about so many substances around us, so many matters around us. And yes, what I found once about cold drink, soft kind of drinks like black color drinks or orange color of drinks. Okay, what is that? I was wondering how to prepare this at home. And yes, it was quite impossible for me, but I was thinking about it. And then I started reading about the so many types of soft drinks, which is black in color or orange in color. So many names in the market with different names. Of course, that we should not consume, it's not good for health. But how to prepare that, I was thinking about that. So what happened, I checked, there are so many things added in that. So many artificial flavors added. Due to this reason, I am saying it is not good for health. Let's talk about the mixture. Yes, that soft drinks, they are mixture actually. And so many mixtures you can see around us. What is the definition of mixture? Let me show you the definition of mixture now. When two or more substances, not necessary two only, it may be 3, 4, 5, 6, 7, 8 like that. So when two or more substances mix together or mix each other without participating in chemical change. What happens when two or more than two substances, when they mix, okay, when they mix together, then chemical change will not be observed. That is a mixture. So chemical change will not be observed means what? Suppose you are taking soil plus sugar. This is mixture, yeah. Soil plus sugar is mixture. Okay. Now if you take like sugar plus salt means NaCl plus H2O, water. This is also mixture, yeah. Okay. Sugar plus water, that is also mixture. Glucose, this is the formula of glucose, C6H12O6 plus water. This is also a mixture. So they are mixture only. What happens in chemistry when two or more substances mix with each other without participating in chemical change? Chemically they do not change. The resulting substance is called mixture. So what happens, NaCl and H2O, when they mix together, then new substance will form, that is solution. I will explain what is solution. So in chemistry what happens, the resulting substance is called mixture when two or more than two substances mix together, mix each other without participating in chemical change. This line is important. Without participating in chemical change means chemically they will not change. Suppose it is NaCl. So NaCl has taste what? Sweet or salt? Salty. So what happens if you add salt in water, its taste will change? No, chemically it will not change, my dear student. Okay. This is glucose. It will provide you instant energy, whether you take it with water or you take it directly. Okay. So better to take it with water. What is the taste? Its taste is almost sweet, yes or no? And if you add in the water, that time also you have say sweet taste only. So chemically they are not changing. Whatever the compounds they are participating, they are not changing and they are forming mixture. So in chemistry, when two or more substances mix each other without participating in a chemical change, the resulting substance is mixture, and it has two types. There are two types of mixture. One is homogeneous, other is heterogeneous. So what is homogeneous and what is heterogeneous? Let me introduce you the next slide now. Dear student, I will surely explain the types of mixture, homogeneous and heterogeneous, but before that let me start with the general properties of mixture. That what are the properties of mixture? Okay. So what happens, the first point is it is made up of two or more substances. Of course, mixture means so many, means more than one, then only mixture. So made up of two or more substances and they are not chemically combined with each other. They do not chemically combine with each other. The property of mixture is listed below and I will give you the next property very soon. So what happens, the main thing here in the mixture, that is chemically they do not change. You must remember this. Dear students, see the next point now. The component of mixtures each keep their original property. Same thing I am repeating again and again. They do not change their property. They keep their original property. Okay. It does not mean that when you dissolve the salt in water, it will become sweet in taste. No, it is not like that. It will be sweet only. Okay. Let me give you the next property now. The separation of components can be easily done. The separation of components can be easily done means, suppose you have soil and sugar. Okay. So, you can separate it, no problem. Soil and sugar you can separate, it is okay. So, this separation of components can be easily done, no problem. Okay. NaCl and water, you cannot do it by your hand, but with some other process you can do it, you can separate that. See, normally if you with the help of glass and your hand and your bowl, you cannot separate dissolved NaCl, but I am not saying that it is totally merged with the water and impossible to separate. No, you can separate. The separation of components can be easily done, but not with your hand. Some special type of equipments and experiments are required. Some reactions are required. Then only it can be done. Okay. Next property now. See, crude oil. What is crude oil? It is a mixture of organic compounds, mainly hydrocarbons. You know, crude oil means the oil what we get under the earth, that is crude oil. Okay. And that is organic compound, and that is mainly hydrocarbon. Yeah, fuels you get, na, you get fuels from like petrol, kerosene oil. So, we get petroleum from under the earth. So, that is only crude oil actually, and that is a mixture of hydrocarbons. Okay. Let me show you the one more example now. See, ink, a mixture of colored dyes. You know, ink, so many dye we take, so many color we take, and then we mix that with the water and some other liquids. Then we prepare it as a ink, then we call it ink. So, ink is a mixture of colored dyes. So, in this way we are seeing what is mixture and what are the possible examples of the mixture. Let me give you the next point now. Gunpowder. What is gunpowder? When you mix sulfur, potassium nitrate and carbon. Potassium nitrate means what? KNO3. Carbon is carbon and sulfur is sulfur. Okay. So, when you mix sulfur, potassium nitrate and carbon, then gunpowder forms. Do you know gunpowder? It is explosive material actually. Okay. Let me give you the next example now. See what happens in seawater, if you tasted, then that is salty in taste. Or normally if you cross from the sea area, okay, and you open your mouth, just you are standing just near the sea and you are opening your mouth, you will feel the salty taste. Why? Because mixture of various salt in the sea and water also. Okay. Why seawater is salty? Because there is so many salt with water. Not one type of salt, so many other types of salt also. Not only NaCl, so many other types of salt and water mixture. So, seawater is also mixture, dye is a mixture, and so many mixtures you saw in the example. Okay. Let me show you the next slide now. Air. Air is a mixture of so many gases: nitrogen, carbon, carbon dioxide, carbon monoxide, oxygen, argon, neon, sulfur, so many gases are there. So, air is a mixture of various gases. Okay. So, yes, we saw so many examples of the mixture. Now, the important question what they ask is about the vinegar, that is vinegar a mixture? We will surely discuss that question also very soon. Let me show you the next slide now. Guys, is vinegar a mixture is a question. So, this part I should discuss actually, because you do not know now that vinegar is a mixture of or not. Okay. Now, let us read the answer once. Let me show you the answer now. Guys, vinegar is a homogeneous mixture. Now, word came homogeneous. What is homogeneous? I will explain now what is homogeneous in this lecture only. So, vinegar is a homogeneous mixture of water and acetic acid. What is water? Water is H2O. Water is H2O, means H2O, okay, and acetic acid. So, what is acetic acid? Acetic acid is CH3COH. It is CH3 COOH. The mixture of water and acetic acid, this is called vinegar. I hope you understood what is vinegar. So, vinegar is a mixture of acetic acid and water. So, is this a mixture? Yes, it is a mixture, because can you see that this compound and this compound, they are mixing together. So, this is mixture. Okay. So, vinegar is a homogeneous mixture. What is homogeneous? I am explaining, do not worry. Next, it is a solution phase. It is a solution because the mixture created has only one phase. Yeah, actually this is liquid in state, not gas or solid. So, this is a solution. So, what is vinegar? It is a mixture of water and acetic acid. Is it a mixture? Yeah, it is a mixture. Homogeneous or heterogeneous? Homogeneous. Now, let me tell you the types of mixture, that what are the types of mixture possible. Dear student, what are the categories that mixtures can be classified into, or what are the types of mixture? So, first is homogeneous and second is heterogeneous. I will explain that, okay, just a moment. So, what is homogeneous mixture and what is heterogeneous mixture? Let us discuss about the homogeneous first. Okay, what happens? Once upon a time, what I was doing, I was adding sugar in water. Okay, I took 2 cup 1 and cup 2. What I did, I added 2, here is a water, same amount of water level. I added 2 spoon sugar in both the cup, 2 spoon, 2 spoon. And here what I did, I shaked properly in A, and in B what I did not shake. I just added, I did not shake. But here I added and I shaked also completely. All the sugar successfully dissolved in the water. Then what I did, I started sipping that. Okay. Then what I found is, it is sweet in taste. You already know this, it will be sweet only. Okay. Let me tell you important part here. What I observed is, when I started drinking this water, this sugar added water, then I found it sweet in taste, and that sweetness was same actually, means the amount of sweetness was same from each and every corner of this cup. From the very first layer, same sweetness, from the bottom layer, same amount of sweetness, at the middle also same amount of sweetness. Dear student, here the scenario is different. When I started drinking this, okay, then I felt, means no sugar, but yes, I added sugar. Then, but I decided that I will drink whole, because I added sugar. So, I have to get sweet taste. Okay, I continued. What I found is, as soon as I am just proceeding towards the bottom, my sweetness amount is increasing. The taste of sweetness, that is increasing slowly, okay, and the bottom part was the sweetest. I want to say that from this cup, from cup B, I did not find same taste, uniform taste in overall solution, in throughout the solution. But here I found exactly same taste from all the parts, all the corner of the cup. But here I found different taste from different corner of the cup. So, if you find uniform taste in any solution, that is called homogeneous mixture, and this was the heterogeneous mixture. Uniform taste is not there, here is uniform taste, homogeneous, heterogeneous. Let me show you the definition of homogeneous and heterogeneous now. Homogeneous mixture possess the same property and combination throughout the mass. So, from all the corner you will find same property, same amount of sweetness. Heterogeneous mixture possesses different properties and different composition in various parts. I told you, from this cup I found different types of taste. So, this is homogeneous, this is heterogeneous. I hope you understood homogeneous and heterogeneous. Okay. So, this is the mixture, their types, they are examples. Thank you.